Hello everyone, welcome back to this channel. So here we are going with the data structure and algorithm series. So in the previous video we have seen the introductory part for the AVL tree as well as the introductory part for the AVL tree rotations. So in this video we're going to see the AVL tree rotations by using the example. Now let's discuss about the RR rotation. Okay, so when the BST means balanced search tree becomes unbalanced due to the node is inserted into the right subtree of the right subtree of A. Then we perform the RR rotation. RR rotation is an anti-clockwise rotation which is applied on the edge below a node having the balance factor is -2. So in the example, this tree is unbalanced tree because it's having the -2 as the balance factor, and means this is unbalanced because the C node is inserted at the right subtree for the B node, and the B is already a right subtree part for the root node. Okay, so because of this, it becomes the unbalanced. Okay, or we can say that it's the right unbalanced tree. So here, what we can do that the means uh so we are going to apply the right rotation on the edge or on the node below having the balance factor is -2. So the next node having the minus factor is having the balance factor is -2 is B. So we need to perform the anti-clockwise left rotation on the B node. Okay. So after applying the rotation, our balance tree looks like this. Okay. Now LL rotation. Now the LL rotation is completely opposite to the RR rotation. Means in an LL rotation we need to perform the clockwise rotation. Okay, so we can take the example that for the left unbalanced tree. So this is the left unbalanced tree. Here the balance factor for the root node is 2. Okay. Um, so when such a condition appears, what we can do now means the node which is at the below level for the node having the balance factor is 2. We perform the right rotation or clockwise rotation for that node. Okay, so as in this example, the B is having the means B node is at the below level for the C. Okay, so we are going to perform the right rotation, or we can say that clockwise rotation for that particular B node. Okay, so after performing the right rotation, then our balance tree looks like this. Okay, now LR rotation. So LR rotation is the combination of the left as well as right rotation. Okay, so because here we are performing the right as well as left rotation, so it's called as double rotation. Okay, so double rotations are a bit tougher than the single rotation, which has already explained in the previous slides. Now let's take the example. This is the unbalanced tree which is having the balance factor as a 2. So first RR rotation is performed on the subtree, and then LL rotation is performed on full tree. So by full tree we means that the first node from the path of inserted node whose balance factor is other than -1, 0 or 1. Okay. So here a node B is inserted into the right subtree of A, which is already the part of the left subtree of C, because of which C has become an unbalanced node having the balance factor is 2. So this case is a LR rotation where the inserted node is in the right subtree of the left subtree of C. Okay. As LR rotation is RR plus LL rotation. So hence RR means anti-clockwise on subtree rotated at A is performed first. Okay, by doing the RR rotation, simply RR rotation, single rotation. Okay, then node A has become the left subtree of B. Okay. After performing the RR rotation, node C is still unbalanced because it's having the balance factor 2, as inserted node A is in the left of C. Okay. Now we perform the LL clockwise rotation on full tree. On the node C, um, okay, so node C has now become the right subtree of the node B. A is the left subtree of B. Okay, so here we are getting our balanced tree. Okay. Again, briefly, I'll explain these all steps. Now, look at the first step. If suppose the R tree is looks like this, means a newly added node is inserted into the right part of that particular node, which is already the left subtree for the root node. Then the root node balance factor will be like 2. So it's the condition for the LR rotation. Okay. Then what we need to do now? We need to do the anti-clockwise rotation. Okay. So we need to do the anti-clockwise rotation for the subtree. Okay. For these subtree like from A and B. Okay. So after performing the rotation anti-clockwise, that is RR rotation, then our tree is looks like this. Okay, so this is the condition for the left unbalanced tree, as we have already seen this left and how to solve this left unbalanced tree in the previous. So same applied. After that, the same particular steps are we are going to apply it here onwards. Okay, like means we need to perform the clockwise rotation over B. So after applying the clockwise rotation, our tree will be sorted. Now we'll see the RR rotation. Okay, so RR rotation. So RR rotation is nothing but a left rotation plus right rotation. Okay, so we'll take the example. So as you can see here, the B node is inserted at the left part for the C, and C is already at the right part for the A. So because of these, the balance factor of A is 2. So this the condition is for the RL rotation. So here we need to perform the left rotation first, then right rotation. So what we need to perform now, at this particular subtree, we need to perform the clockwise rotation, that is left rotation over here, so that it became the right unbalanced tree. Okay, so this condition is the right. This condition is for the RR rotation. So we have already seen the RR rotation in previous slides. So same formula or same steps we are going to follow here. So we are just doing the anti-clockwise rotation on this particular tree. So at the end, our balanced tree looks like this. Now, in the next video, we're going to see the example for the constructing the AVL tree by using the rotations we have already seen. Thanks for watching.